Okay, that's the acceleration. Where you go to find the tension? To any of the two equations. Any equation with the argument machine dealing with two objects. Same thing, except that you will have two equations. Very simple. Okay, next. The next topic is friction. And we will do this experiment in class also. We will prove the theory of friction in our lab as well. So, friction. Dealing with friction, Da Vinci was one of the first persons that studied friction, and he found that the friction can be of two types. One, static and kinetic. What will be? And both friction will depend, also studied by Da Vinci, that both friction, static or kinetic friction, will depend on two things. This is dependent on the materials in contact, or the surfaces in contact, surfaces in plural, both surfaces, and the actual area of the surfaces, and the load. This Da Vinci found it. That depends on the surfaces and depends on the load. The static friction, here you have. So let's say that we have this, and I want to move this with a certain force applied to here. So you can see that if I apply force to here, and this is not moving, right? By the Newton's first law, the force that I am applying has to be equal to another force that is in the other side. And that force is the frictional force. So in that case, the frictional force is static or is kinetic? It's static. But then suddenly will be a moment when I reach a maximum critical force. It's a critical moment when this will have the transition between not moving and moving. So you can see that if I start applying force at a certain time, you will have a critical force. And then after that critical force, if I continue applying force, I will move the object. The friction is still there, but there are two types of friction here. One, the static, while it was not moving, because since I was applying a force, in the other side have to be a force. And you can see that I'm applying a force on the scale. So, but sometimes you will push in such way that you will overcome the static friction. And that happens very frequently when you have to push a car, right? And you start trying to push, and you can't. When you add somebody else, you start pushing, there will be a moment when you overcome, and then you relax, and you say, wow, wonderful life. And originally you couldn't, because you have to overcome the static friction. Reach the critical value, and then the friction is kinetic, which goes down. So if you thinking on that examples, so if we graph the force, and that we will do in the lab here, on using Lower Pro, you will see this. If we study the force versus time, or the force we apply versus time, or the force versus the force applied, you can see that if I apply 0 Newton, there is no force of friction. Now there is no force of friction. Then, if I apply 10 Newton, and I don't move the object, here will be also 10 Newton. If I apply more force, and I don't move the object, will be the same force. So basically, the same force horizontal, not at an angle. The horizontal force, which is the one that I have to take in account. But at a certain moment, If you reach the maximum value, then the friction will go down and we'll do this. This graph, we will prove it here using lower problem. Here we have three areas important. Number one, the area of static friction. Number two, the area of maximum static friction, critical value. And number three, kinetic friction. Summarizing that graph, we can say that number one, the force of friction, which we will label lowercase f. Some books will have FFR. Lowercase f in dynamics means friction. The static friction I will label Fs always will be less or equal than the maximum static friction. A maximum or critical we will label Fx max. The only way to find that when it's less than the maximum static friction, the only way to find it is applying the Newton's first law along the particular axis. Can be x, can be y. Equal to 0. This is the only way you can find that friction, applying the Newton's first law. Second, according to Da Vinci, the static friction, Fx max, will depend on two things. On the surfaces in contact, which is related to a coefficient that is called coefficient of friction, or frictional coefficient that we label mu. And the load will be related to the normal force. So, my Fx max will be equal to mu S n. N is the normal force. Sometimes we label, instead of labeling Fn, we can label N, capital. This means the normal force. Like tension is capital T, N is capital N. Also, you can find this force, which will be equal to the minimum force applied on the opposite axis, minimum force applied to move the object, using the Newton's first law. This Fx max can be either the minimum force you need to apply to move the object, or mu s Fn. Either way, you can find it. And finally, the third one, the friction kinetic, can be found if you have the coefficient of friction kinetic and the normal force. This formula, it is found experimentally. Most of the time, the coefficient of friction can be found experimentally. Doing an experiment, you can find the coefficient of friction. We will do that experiment as well to find the coefficient of friction in class between two surfaces. Also, you can find this using either the Newton's first law or the Newton's second law, depending if it's moving at constant velocity or if it is accelerating. So even that the